Hello and welcome to section 13.1, which is on experimental and theoretical probability. So there's several terms we need to go over first just to remind ourselves of some of the terminology involved with probability. An outcome is a possible result of a situation or experiment. An event is a single outcome or group of outcomes. And a sample space is a set of all possible outcomes. So if I flip a coin, the result is an outcome. If I flip a coin 10 times, that group of outcomes is called an event. And the sample space would be a head or a tail because those are the two possible outcomes I would have from flipping a coin. Probability, the number of favorable outcomes over the number of possible outcomes. So how many good, like how many times did you get what you wanted? Out of how many times did you try, basically, is how you can look at that. And we can write probabilities three different ways. You can write them as a ratio, which is a fraction. You can write them as a decimal, or you can write them as a percent. Experimental probability measures the likelihood that the event occurs based on the actual results of an experiment. So it's based on something that has already happened. Okay, so the probability of any event would be the number of times the event occurs over the number of times the experiment was done. So in my example here, a park has 538 trees. You choose 40 at random and determine that 25 of them are maple trees. What's the experimental probability that a tree chosen at random is a maple tree? And then I also want to know about how many trees in the park are likely to be maple. So we need to do two things here. First thing is just to determine the experimental probability, which if we look right here, it says number of times the event occurs over the number of times the experiment is done. So how many times did they find a maple tree? 25 out of the 40 trees that they checked. And you can reduce that to 5/8. You could also change it to a decimal, which is 0.625. Or then go ahead and change it to a percent. It would be 62.5%. Then the second part of the question says about how many trees in the park are likely to be maple. So a couple different ways you could do this. I already figured out it's 62.5%, so I could just take 62.5% times your 538. Or I could go ahead and use the fact that 5 out of 8 trees are maple. I don't know how many out of 538 trees will be, but I can figure it out by doing this proportion. So you're going to crisscross like you normally do there. So 8x equals 2,690, and then you go ahead and divide by 8, and therefore it is about 336 trees out of the 538 would be maple, based on our experimental probability. So then we also have theoretical probability, and that's something that could happen, not something that did happen like the experimental probability. Theoretical probability describes the likelihood of an event based on mathematical reasoning. Okay, so my example here, what's the probability of rolling an even number on a dice? Well, how many even numbers are there on a dice? On one die. 3 of them are even out of 6 numbers total, and therefore my theoretical probability is 1/2, or 50% if you want to write it that way. Complement of an event consists of all possible outcomes in the sample space that aren't part of the event. So if I want to roll an even number on the dice, then the odd ones are the complement to my even ones. Together they would make up 100% of all choices, right? The evens and the odds. The probability of an event and its complement has to equal 100% or 1 if you're doing decimals. So my example for this one, a jar contains 10 red marbles, 8 green marbles, 5 blue marbles, and 6 white marbles. What is the probability that a randomly chosen marble is not red? Well, first thing I need to do is add them all up. So it looks like I have 29 total. And there are 10 red ones, which makes 19 of them not red. And you reduce it as low as you can. and then you can just leave it as a fraction, or you can change it to a decimal or percent. But 19 out of 29 of those marbles, you have a 19 and 29 chance of getting a marble that is not red when you go ahead and reach into the bag and pick a marble or a jar. Okay, so bring that knowledge of probability with you, and we will talk about it more the next time I see you. Have a good night.